This little phrase is referencing what we do to the carrier assembly of that simple planetary gear set. So the carrier assembly, that's the piece in the middle that is connected to my planetary pinions. Right? Planetary carrier, carrier assembly, different manufacturers will call it slightly different things. It's the carrier. So I-O, H-R-O-U. That's the order of the letters you guys need to remember. And each one of these breaks down into a pair. So that I, when we said it's over, the I represented input. So what I'm saying is if the carrier is the input, there's my carrier assembly right in the middle. Let me redraw that. I want to point to the sun. Right. So there's my carrier assembly, that big Y guy right in the center. If the carrier is the input, then what we're going to achieve is overdrive. You guys remember the definition of overdrive, underdrive, direct drive. I'm not going to spend a ton of time going through that. If we overdrive something, it means the output is spinning faster than the input. That's what an overdrive transmission is. If we underdrive something, that means the input is spinning slower. Sorry, the output is spinning slower than the input. Underdrive, first gear, second gear, third gear, right? 4-to-1, 3-to-1, 2-to-1, those are all underdrive ratios. Because when we underdrive something, while the speed goes down, the torque goes up. Well, that's going to get the car moving for us. That's going to get the truck moving for us. Then as we start to accelerate, we run out of speed in that gear and we shift into the next underdrive and then the next underdrive. And then we get into a direct drive where we have a 1-to-1 ratio. So my torque and my RPM are exactly the same on the input and the output, excluding any frictional losses. And then we get into an overdrive where my output is actually spinning faster than the input and the speed has gone up, but the torque has gone down. So make sure you guys brush the cobwebs off your level 1 material, torque, RPM, speed, all of that information with regards to gear ratios, because there are going to be questions on your exam that are going to kind of query you on that and say, hey, if torque goes up, what happens to speed in a gear ratio that represents this example? Remember that your gear ratios are always, always, always expressed as something to 1. And that 1 is always going to be the output. So if I have a 3.25 to 1 ratio, that's going to be an underdrive, and that means that my input shaft is rotating 3.25 times, whereas my output shaft is only rotating once. If I have a gear ratio that is 0.25 to 1, oh, where'd my window go? There it is. If I have a gear ratio that's 0.25 to 1, that means that my input shaft only rotated a quarter of a turn. My output shaft rotated once. Well, the output shaft is rotating faster. That is an overdrive. So make sure you guys remember your gear ratios from your level 1 material, because that's going to make everything a little bit smoother as we move along here. So getting back to my it's over Honda's rule our universe, if the carrier assembly, if that guy is the input, so there's my carrier assembly. If we bring torque into this carrier assembly, we drive this carrier assembly, we are always going to achieve an overdrive. Doesn't matter if I hold the sun gear, if I hold the ring gear and the sun gear becomes my output, or if I flip those around and I output my ring gear and I hold the sun gear, doesn't matter which operation, I'm still going to achieve an overdrive. And I'll show all of this to you guys in a second. In fact, why don't I take that right now? So I am going to take you over to this camera. And I'm going to pause that screen for a minute. So make sure that you guys have got your camera kind of wide open, bright-eyed and bushy-tailed, so you can see my little Consulab planetary gear set there. And we said that it's over Hondas rule our universe. See if I can do this without getting my headphones in the way here. So there's my simple planetary gear set. There's my ring gear around the outside. Pretty easy, pretty obvious. There's my sun gear in the center. And of course, there's my planetary carrier, which is pinned to those 3 green gears. So there's my simple planetary gear set. So we said that the first one was and of course, everything can rotate as a whole. I can rotate these guys around. You'll see that in a second. We said that if the carrier is an input, then regardless of what I'm holding or outputting, I'm going to achieve an overdrive. Well, here we go. Watch this. So here's my carrier assembly. So I'm going to spin the carrier assembly. What you guys need to focus on is the output being the sun gear. All right, because I'm going to hold onto the ring gear. So the ring gear can't go anywhere. And I'm going to spin the carrier assembly. Well, look at the speed of that sun gear as an output in relation to the speed of my carrier, which is the input. Is that sun gear spinning faster? Sure, absolutely it is. It's spinning way faster. In fact, I can tell you it's spinning about 4 times faster. So if we go to this point, so we've got everything lined up, we can watch that I've had so there's 1 rotation of the sun, 2 rotations of the sun, 3 rotations of the sun, 4 rotations of the sun, and then back to where I started. So my output spins 4 times faster, or expressed as a ratio, that would be 0.25 to 1. Because watch what happens when I rotate that carrier a quarter of the turn. My sun gear has gone 1 full turn, so there's my output. There's my 2-1 ratio, blank to 1, something to 1. My carrier only went a quarter. So it's 0.25 to 1. Doesn't matter what I hold or what I output. If the carrier is the input, I'm always going to achieve an overdrive. So we'll flip this around, and I'm just going to pin my sun here, so my sun becomes the held member. And now when I drive my carrier assembly, so my input is the same, right? I'm still driving the carrier, but look at my output. Well, now my output happens to be the ring gear. And we can see the ring gear absolutely spinning faster than my carrier is. And eventually, as I go all the way around, these 2 guys will line up again. So we're full at the top, we're lined up. Well, let's look at the ratio on that one. We said that if the carrier was an input, I was going to achieve an overdrive. Well, let's see what it takes to get me 1 full turn on the output. So here comes my ring gear. My ring gear is right back to where I started, and I had about 3/4 of a turn on that carrier. So my gear ratio is 0.75 to 1. Right? 1 full turn of the output required 0.75 turns of the input to get me there. Both of these scenarios are overdrives. So if the carrier is the input, it doesn't matter if I'm holding the ring gear and the sun is the output, or if the sun is being held and the ring gear is the output, doesn't matter. I get 2 different ratios. One of them we said was a 0.25 to 1 ratio. The other one was a 0.75 to 1 ratio, but they're both overdrive ratios. So if you input the carrier, you are always going to get an overdrive application in a simple planetary gear set. So far, so good. We understand the I/O, the it's over part of it. Awesome. Let me flip back to this guy for a second. I got my cable all wrapped around my head here. I'm going to strangle myself in a minute. There we go. So that was the I/O, right? That's the it's over part. The over is easy to remember because the over turns into overdrive, right? So it's over just turns into input and then overdrive. The second part, or the second third, if you will, because there's 3 parts to this, is the HR. Well, the Honda's rule turns into held and reverse. And that simply stated means that if we hold that carrier assembly, we are always going to achieve reverse. We will have a fast reverse and a slow reverse, but we are always going to achieve reverse. And what you guys might want to do as we're kind of motoring along here is just, put a little symbol between those two, indicating that those two are tied together as a pair. Those two are tied together as a pair. And of course, the next one we come to will also be tied together as a pair. So if we hold that carrier, we are always, always, always going to achieve reverse. And as I said, we'll have a fast reverse and a slow reverse, but we're always going to achieve reverse. So let's go back and have a look at that planetary gear set again. And we said we are going to HR, right? So we're going to hold that. So let me line these guys up one more time, spin these around, just because it makes the visualization a little bit easier. There we go. So now we said we're going to hold the carrier. So again, silver triangle, that's my carrier assembly. I'm going to hold that carrier. I'm going to put my little magic holding device in here somewhere. Where's the pin? Oh, pin's over here. Okay, that's fine. We'll just go like this. So I'm holding my carrier so the carrier can't go anywhere. So that means that my sun gear can be an input and my ring gear would have to be the output, or the ring gear can be the input and the sun gear will be the output. What I'd like you guys to watch is what happens to the direction of rotation. So depending on how you're looking at this and what your screen looks like, I'm going clockwise with the input. The ring gear is the input. The sun gear is the output because I'm holding the carrier. Well, which direction is the sun gear spinning? The sun gear is spinning backwards. Right? The sun gear is going in reverse. What's the ratio? Well, let's figure it out. Let's see if we can get things lined back up to where they were. So everything is lined up perfectly here. Let's see what it takes to get one rotation out of that sun gear. There's approximately one rotation out of that sun gear. And I went, I don't know, maybe about a third. I started off over here and wound up over here. So I went about a third of the way. So we have a ratio of approximately 0.3 to 1 in that reverse scenario. We said the other possibility was the sun gear is the input, which would make the ring gear the output. So if I drive the sun gear, you can clearly see that that ring gear is now going counterclockwise. What's the ratio on that one? Well, let's see. What's it going to take to get one revolution of that ring gear? Because remember, the ratio is always expressed as something to 1, and that 1 is the output. So what's it going to take to get one full revolution of that ring gear? Well, there's 1 on the input, 2 on the input, 3 on the input. So I've got a 3 to 1 ratio if I drive the sun, hold the carrier, and the ring is the output. Or if I drive the ring and the sun is the output, I have a 0.3 to 1 ratio. So I've got a fast reverse and a slow reverse. I have an overdrive reverse and I have an underdrive reverse. We're not too concerned about the ratios. Obviously, we don't have 2 reverses in a car, but the goal of this story, or the moral of this story, is that you guys understand if we hold the carrier, we are going to achieve reverse, because the only other possibilities are now input and output. And it doesn't matter if I input the ring gear and output the sun, or if I input the sun and output the ring gear, I'm always going to achieve reverse. One will be a fast reverse, one will be a slow reverse, but I'm always going to achieve reverse. And in a simple planetary gear set, that's all we're trying to accomplish. Hang on to that carrier. We're going to achieve reverse. Some textbook questions, some exam questions are not necessarily going to ask you about the carrier, but if you know what the carrier is doing, process of elimination, you can very quickly figure out what the answer to the question is. So last one here is, if the carrier is the output, then we are going to achieve an underdrive. So if the carrier is an output, that means that my ring gear is going to be the input and the sun gear is going to be held, or the sun gear is the input and the ring gear is held, either the sun or the ring, but the carrier always has to be the output in this particular scenario. So there's the last one that you kind of want to group together. right? So those guys are a pair. And again, we're talking about the carrier assembly. All three of these are referencing this carrier assembly. It doesn't matter what we do to the sun. The sun could be an input, the sun input could be held, the sun could be an output, or the ring gear could be held, input or output. This little rhyme, this little phrase, this little meme, it's directly related to the carrier assembly. What are we doing to the carrier? And if we know what we're doing to the carrier, then we can very quickly figure out what we're doing to everything else. So the last couple of points on here, output. Well, if the carrier is going to be my output, then I'm going to achieve an underdrive each and every single time. Doesn't matter if the sun is the input or the ring is the input or the sun is held or the ring is held, because those are my only possible choices. I am going to achieve an underdrive every single time. Let's just get things lined up. So if we hold that ring gear, hang on to the ring gear, the carrier is going to be our output. Well, that means the sun gear has to be the input. And we said it's over. Honda's rule, our universe. Well, we're going to have an O, right? A U, our universe. The U, represents underdrive. Well, look how fast that carrier is going to spin in relation to how fast the sun gear is going to spin. Is it spinning slower than the sun gear? Yep. Everybody nod their head. Yeah, absolutely it is. If the output is spinning slower than the input, then we have an underdrive. How much of an underdrive? Well, let's see. What's it going to take to get one full rotation of that output? So there's one rotation of the input, two rotations of the input, three rotations of the input, four rotations of the input. So I have a 4-to-1 underdrive. There's my underdrive, which would be a pretty realistic first gear in a lot of today's transmissions, a lot of today's scenarios. So that would be one example of achieving an underdrive. The other example of achieving an underdrive would be to hold the sun gear and drive the ring gear. So let's just flip that around, because we still want the carrier to be an output. So let me just put a pin in my sun gear here so it doesn't go anywhere for me. Perfect. So there's my sun gear pin, so it can't go anywhere. So we're holding the sun gear, we're driving the ring gear, we're still looking at the carrier as an output. Let's see what happens. Better be an underdrive. Did it go slower than my input? Absolutely, because there's one full turn of my input and the carrier only went 3/4 of a turn. So it looks like to get one full turn of that output, I'm about 1 1/3, give or take a little bit. So I would have a underdrive of about 1.3 to 1, give or take a little bit. 4 to 1, that's absolutely an underdrive. 1.3 to 1 is absolutely an underdrive. So I've got 2 underdrives if the carrier assembly is being the output, right? Our universe. If this guy is the output, we are going to achieve a U. What's U? U is underdrive. Make sense? Good. So how many have we covered? We covered the 2 overdrives. We said that if the carrier was the input, then we were going to achieve a fast and a slow overdrive. If the carrier was held, we were going to achieve a fast and a slow reverse. And if the carrier is the output, we are going to achieve a fast and a slow underdrive. So that's 6 so far. I promised you guys 7. Here comes number 7. Let me reset this around, dial everything back up to the top. Number 7's a little bit trickier to show you guys. So we've had overdrive, we've had underdrive, we've had reverse. What haven't we had yet? What are we missing? Let's see how many of you guys maybe read ahead a little bit and went, hey, we haven't covered this one yet. What are we missing? Dan's got it, direct drive. We are missing direct drive. Well, here's direct drive. And every year when I teach this, I don't know why everybody resorts to drive and gets that word backwards with hold. To achieve a direct drive in any simple planetary gear set, we're going to take any 2 members and we are going to drive them at the same speed. and the remaining member is sandwiched. It's along for the ride. So watch what happens when I drive the ring gear and I drive the carrier assembly, right? There is no rotational difference between those two components. So the sun gear has to come along for the ride. One revolution of the ring gear, one revolution of the carrier. So these two guys are locked together, and my sun gear comes along for the ride, and I have a direct drive. So if my input were the ring gear and my input was the carrier, then my sun has to be the output. So I'm driving any two members at the same speed. If I drive the sun gear and I drive the ring gear at 1,000 RPM, then we get them both to the point where they started, I've got one revolution of my carrier. So in that scenario, the carrier was an output. So previously the carrier was an input. This scenario, the carrier was it doesn't matter what the combination is. I can take any of these two guys and drive them at the same RPM, and the remaining member has to come along for the ride. So the catch here is that nothing is being held, because if I'm driving my ring gear and I'm driving the carrier, I can't hold the sun, or the sun wouldn't turn. And if the sun doesn't turn, nothing turns. So to achieve direct drive, take any two planetary gear members, rotate them at the same RPM. Doesn't matter if it's 1,000 RPM or 100 RPM or 5,000 RPM, you will always achieve direct drive if you take any two members and rotate them at the same speed.